Okay, Advanced Algebra, Function and Graphical Reasoning, Standard 5.2. The imaginary unit, I is equal to the square root of -1. That might seem like a strange thing to do, but it does sort of give birth to new mathematical properties when we consider taking the square root of negative numbers. Ordinarily, you can't do that. If you take the square root of a negative number, it would be not defined because any number times itself is always positive. But when we create this imaginary unit, that allows us to take square roots of negatives. So here's an example of that, the square root of -45. Now ordinarily, again, there is no such number because positive times positive is positive, negative times negative is positive also. But when we have a negative here, if we were to remove this blue part here, the -1, that allows us to work with the other two parts. Now what happened here is, you probably have simplified these before. We removed the largest perfect square, which is 9, from 45, leaving behind this 5. The square root of 9 is 3. We call the square root of -1 I. And then the yellow part is just sort of the leftover part that we can't work with. So it's 3I root 5. Just the same as if you took the square root of regular 45, it would be 3 root 5. But now that we have this imaginary unit defined, we're able to take the square root of -45. Just another quick example. Again, we've got to do something about that negative. 4 is the largest perfect square that goes into 60. 4 goes into 60 15 times, but we can't ignore the negative. We have to designate the square root of -1. The square root of 4 is 2. The square root of -1 is I. And the square root of 15 is just that. If I is there, or if there's the potential for it to be there, we call it a complex number. Okay, we'll work more of these when we add and subtract and multiply and divide. The complex number is a number of the form a plus bi. Every number that exists is complex because you could always sort of turn off the I by making b 0 and just working with the real part, which is a. Real means there is no I, and imaginary means there is an I. That's a kind of a good way to think about that. But when we put an a plus bi, that's basically any real combined with any complex. Conjugates are designed to get rid of I if you want to. And we'll see an example of this later, but the conjugate of 7 minus 5i is simply 7 plus 5i. Okay, you just change the sign in the middle. If you were to multiply 7 minus 5i and 7 plus 5i, which we'll do in a future video, it gets rid of the I for you. Okay, so that's a conjugate, something to keep in mind. So complex numbers, a plus bi, any number of that form. Here's 2 examples. Conjugates have varying middle signs only. The standard says to define complex numbers such as I squared is -1. Okay, so that's another way of saying I is the square root of -1, as we'll see later. And show that every number has the form a plus bi and has the conjugate where you change that middle sign.